Hello friends, welcome to our aimstoday YouTube channel. In today's IIT-JEE NEET Foundation class, from physics subject measurement topic we are going to continue. So in this video, we are going to learn about rules for writing the SI units. Rules for writing the SI units. So all the symbols of the fundamental units should be written as they appear in the table of SI units. Here the table means International System of Quantities. The ISO has designed one table called International System of Quantities. So in that table, so all the units in what way they have been mentioned, in the same way we have to use while we are making use of the fundamental units or derived units. Suppose 5 meter. If I write 5 meter like this, 5 after capital M, this is wrong. This one is wrong representation. So Y means the standard symbol for meter is small m, not capital M. So 5 small m is correct one. In the same way, 10 kg. If we write like this, then it will be wrong. So we have to write it as 10 kg like this. So like this, the first rule is the symbol should be written as they have been mentioned in the table, ISQ table. Next. So some of the units represented by the names of the scientists as an honor for their research in the respective fields. So the full name of such units, if we are mentioning the unit with their full name, so then it should be written with lower initial letter. Then it should be started with lower initial letter. So Newton, if we write Newton with starting with capital N, it will be, this is wrong. We have to write it as Newton starting with small n. Next, Ampere starting with capital A is wrong. We have to write it with Ampere starting with small a. Next, Coulomb, the unit for charge, with capital C, wrong. We have to write it with small c, spelling mistake here, Coulomb, Coulomb, Coulomb. So this is the second rule. If we are writing the unit by mentioning its scientist name, the initial letter should be in small letters. Next. So actually, the unit of force is kg meter per second square. The unit of force is kg meter per second square. But it is named after the scientist called Newton. So the symbol of unit named after a scientist should always be written with the capital letter. So we can, instead of mentioning with the name, if we want to mention the unit with a single letter, then it should be represented with capital letter. So now writing the Newton name with small n is wrong. We have to write it with capital N. So if you want to write Ampere with small a, if we written, it is wrong. We have to write with capital A. Next, Kelvin. It should be represented by capital K. So when we are using the scientist name as the unit, we want to mention it with a single letter, then that should be a capital letter. Next, punctuation marks like full stop, comma should not be used after the symbol of the unit. 7 meter full stop is wrong. 7 meter we have to represent as only 7 meter without full stop. 25 kilograms full stop is wrong. 25 kg, that's all. 6 newtons is wrong. 6 newtons. Like that we have to represent. A unit should always be represented in a singular form. A unit should not have plural forms, like 7 meters is wrong. 7 meter is correct. 25 kgs is wrong. 25 kg is correct. 6 seconds is wrong. 20 second is correct. No space is used between the symbols of units when written together. If I want to write joule second, if the unit is joule second, so here we have given space, so that is wrong. Without space, if we write joule second, then it will be correct. Half kg meter, here gap is given, that is, this is wrong. Half kg meter, this is right. 60 Newton meter, gap should not be given. 60 Newton meter like this, correct. So one space is left behind the last digit of the numeral and the symbol. Here I want to write 5 joule seconds. Between the numeral and unit, there should be one space. So here we have not given the space. So this is wrong. Here we have given the space. Between the numeral and unit space we have given, but the two units written together. This representation is right. Next, half kilogram. Without space we have written, which is wrong. Half kilogram. Here space we have given. This is right. 6 Newton meter. No gap. Wrong. 6 Newton meter. One space is there. Right. So let's learn about multiples and submultiples of units in this video. So let's start with multiples of units. So if you want to measure the length of a classroom, so we can take the help of meter scale, and with the help of standard unit meter, we can measure the length of the room. 5 meters, 10 meters, like that we will get the value. With the same meter scale, is it possible to measure the distance between sun and earth? It's highly impossible, because it's a very large distance compared to the distance between the room, this corner and that corner. So this much large distance we cannot measure with the help of meter scale. It's highly impossible. So we need some special kind of instruments or some special kinds of techniques for measuring this kind of distances, and the meter is not the suitable unit, because meter means it's a very small length. Its magnitude is very, very small. So that meter is not also not the suitable unit for measuring these kind of distances. So there is a need of bigger units than meter for measuring large distances. So there is a need of bigger units. So the units obtained by multiplying a given measurement unit by an integer greater than 1 are called multiples of a given unit. We are telling that there is a need of bigger units. How to get that bigger units? When the given standard unit, if it is multiplied by an integer greater than 1, then we will get multiples of the given unit. So in this way we will get multiples of the units. So let's see some SI multiples of meter. So let's see their value and multiple name and multiple symbol. So if you multiply with 10, now meter is the standard unit. If the standard unit meter is multiplied by 10 power 1, means with a factor of 10, so then it will become 10 meter. So and its name is decameter, and the symbol is DAM. All letters should be small letters, DAM. In the same way, if you multiply with 10 square, that means 100. It will become 100 meter. Then its name is hectometer. Symbol is HM. 10 cube meters. If we multiply with the 10 cube, 1000. So 1000 meters, which is equal to kilometer. Symbol is KM. Here kilo stands for 10 cube. Kilo stands for 10 cube. Means the standard unit m, if it is multiplied with a factor of 10 cube or 1000, so then that unit is named as kilometer. In the same way, 10 power 6, it is termed as megameter. 10 power 9, gigameter. Symbol is capital G, small m. Megameter symbol also capital M, small m. Next, terameter, 10 power 12. Terameter, capital T, small m. Next, petameter, factor is 10 power 15. Capital P, small m. Next, hexameter, 10 power 18 is the factor here. Capital E, small m. Next, zetameter, 10 power 21 is the factor. Capital Z, small m. Next, yottameter, 10 power 24 is the factor, and capital Y, small m. Except the first three, remaining all multiples symbol starts with the capital letter. Megameter, gigameter, terameter, these are all symbols starts with the capital letter. So these are the most common multiples of meter. Almost 10 multiples are there. These 10 are the widely used multiples of meter. Remaining other multiples also we can make them obtain from these multiples. Next, submultiples of units. Suppose length of classroom we can measure with meter scale, that we have discussed already. Suppose I want to measure the length of an ant, small insect called ant. I want to measure its length. We can't measure it with meter scale because its length is very small compared to the meter scale. So that's why, so there is need of smaller units than meter, so that even small measurements also can be measured. So because for measuring the length of ant, meter is not the suitable units, so there is a need of smaller units. That smaller units are called submultiples of standard units. So these submultiples or these smaller units can be obtained by dividing a given measurement unit by an integer greater than 1. Means by dividing with 10, 100, 1000, like that. If we go on dividing the standard unit, we will get the submultiples of the given unit. Submultiples of the given unit. Let's see some of the submultiples. So here we have to divide. We have to divide the given standard unit. Means 1 meter by 10. We have to divide 1 meter by 10. So then it will become 10 power minus 1. We can write it as 10 power minus 1. Means if the factor is 10 power minus 1, then that unit name is decimeter and the symbol is dm, small dm, decimeter. If the factor 10 power minus 2, centimeter, 10 power minus 3, millimeter, 10 power minus 6, micrometer. Here micro symbol is mu. It's a Greek symbol. It is pronounced as mu. So this is the symbol of micrometer, mu m. Next, 10 power minus 9. If the factor is 10 power minus 9, nanometer. Next, 10 power minus 12, picometer. Symbol is pm. Next, 10 power minus 15, femtometer. Symbol is fm. 10 power minus 18, attometer, am. 10 power minus 21, zeptometer, zm. 10 power minus 24, hectometer, ym. Here this femtometer, it is also termed as Fermi, F-E-R-M-I. It is also called as Fermi. So here the micrometer is having the special symbol mu m, and the femtometer, it is also termed as Fermi. Remaining all the symbols, the starting letter is small letter and second letter also small letter only. So these are the submultiples. These 10 are the most commonly used submultiples. So how to remember this multiples and submultiples? So we have one shortcut for measuring this submultiples and multiples names, and that shortcut is King Henry doesn't usually drink chocolate milk. With this phrase, King Henry doesn't usually drink chocolate milk. With this phrase, we can remember some of the important multiples and submultiples. Not all 20, but some important multiples and submultiples we can remember with this phrase. So how means? So here, suppose meter, either 1 meter or 1 liter or 1 gram. So this is the, on the basis of, on this basis we are going to define remaining all. So we have taken as, this is the basis. So 1 meter, 1 liter and 1 gram. Because multiples and submultiples for length and mass and time are all same only. Only the whatever factors we have, based on that we have to keep its name. Suppose if we have 10 square or 10 cube grams. Here 10 cube stands for kilo. According to multiples table, it stands for kilo. So then it is termed as 1000 grams, means 1 kilogram. 1 kilogram. So that's why all the multiples and submultiples for all the quantities like length, mass, time are all will be the same. So here this is we have taken as the basis. Basing on this, if we we can multiply to convert to larger units. We have to move the decimal to the left. To convert to smaller units, we have to move the decimal to the right. Suppose this 1 is there. So to convert to smaller unit. So what I have to do? This decimal point I have to keep to the right. Means it will become 0.1. So there it is called as deci. Still, if I want to make it small, still decimal point, it has to move to the right. 0.01 centi, 0.001 milli. Or if I want to increase 1, 10, I can keep 1 0. 10, deca, 100, hecto, 1000, kilogram. So if you see the order, kilo, hecto, deca, meter, deci, centi, milli. This all units names we can remember with this phrase. King Henry doesn't usually drink chocolate milk. So from 10 cube, by this phrase, we can remember the names of the units from 10 cube to 10 power minus 3. Means from kilo to milli. From kilo to milli, these all names we can remember. One more shortcut is there. By this we can remember, by this phrase we can remember the units from 10 power 12 to 10 power minus 12. The multiples names from 10 power, multiple submultiples names from 10 power 12 to 10 power minus 12. And the phrase is, the great man King Henry's daughter Beth drinks cold milk until 9 p.m. Until 9 p.m. In this until word, instead of you, we have to consider the spelling. Consider in that spelling, we have to consider mu in the place of you. So according to this phrase, D means 10 power 12. Starts with the T. T for tera. Great. G stands for giga. Man. M stands for mega. K, king. K stands for kilo. Henry's. H stands for hecto. Daughter. D stands for deca. B, Beth, which is taken as base. Means 10 power 0, 1. So next, drinks. D stands for deci. Cold. C stands for centi. M stands for milli. Until, in the place of U, we have to take it as mu. Mu means micro. Mu stands for micro. Next, 9. N stands for nano. P stands for PM. P stands for pico. So with this phrase, we can remember the names of submultiples and multiples from 10 power 12 to 10 power minus 12. All these names we can remember. Thank you. So thank you for watching our video. Please subscribe our channel and press the bell icon for latest updates.